Welcome to NeoNexus. Please subscribe and hit the bell icon for more updates. Today we're diving into the story of Voyager 1 and Voyager 2, two spacecraft that changed how we see our place in the universe. Launched in 1977, these probes took advantage of a rare planetary alignment, using gravity assist to visit Jupiter, Saturn, Uranus, and Neptune in a single, ambitious mission. Their cameras and instruments revealed the gas giants as dynamic worlds, with storms, rings, and moons more complex than we ever imagined. But the real adventure began after the planetary flybys. The Voyagers kept going, heading for the edge of the solar system and beyond, into interstellar space. Their new mission: to find where the sun's influence ends and the galaxy begins. No spacecraft had ever gone this far. Each Voyager carries a golden record, a time capsule of Earth's sounds, music, and greetings, meant for any intelligent life that might find it. These probes are humanity's emissaries, racing away from Earth at over 35,000 miles per hour. The hope is that someday someone or something will discover our message in a bottle. The Voyager's journey is both a scientific quest and a poetic gesture, reaching out to the cosmos. They've redefined what it means to explore, showing us that curiosity can take us farther than we ever dreamed. Their story is a testament to human ingenuity and the desire to know what lies beyond. Let's follow their path to the edge of everything. What does it mean to reach the edge of the solar system? It's not about crossing Pluto's orbit. The true boundary is defined by the sun's influence, specifically, the solar wind. The sun blows a stream of charged particles, creating a protective bubble called the heliosphere. Inside the heliosphere, the sun's particles and magnetic field dominate. Beyond it lies the interstellar medium, a thin soup of gas, dust, and cosmic rays from the galaxy. The edge is where the solar wind can no longer push back against this interstellar medium. This invisible frontier is called the Heliopause. Before reaching the Heliopause, the Voyagers passed through the termination shock, where the solar wind slows dramatically, and the heliosheath, a turbulent buffer zone. Crossing the Heliopause means leaving the sun's protective bubble and entering true interstellar space. The Voyagers were the first to directly measure this transition. It's not a fixed line, but a dynamic boundary shaped by the sun's activity and the galaxy's pressure. Once past the Heliopause, a spacecraft is flying through material forged by other stars. The data from Voyager's crossing gave us our first real look at what lies beyond our solar system. It's a place where two cosmic environments collide. The Voyager's mission was to find and cross this ultimate frontier, and they did, making history in the process. The edge of the solar system is not just a distance, it's a change in the very nature of space itself. The Voyager spacecraft have been traveling for nearly 50 years, built with 1970s technology, yet still sending data from billions of miles away. Their computers are primitive by today's standards, but their endurance is unmatched. Voyager 2 visited all four gas giants. Voyager 1 took a faster path out of the solar system. Each planetary flyby revealed new wonders: volcanic moons, intricate rings, and magnetic fields that defied expectations. After their last encounters, Saturn for Voyager 1, Neptune for Voyager 2, they began their lonely trek into the outer darkness. The sun faded to a distant star, but the Voyagers kept measuring, searching for signs of the solar system's edge. Today, Voyager 1 is over 15 billion miles from Earth, Voyager 2 over 12.5 billion. They are the most distant human-made objects ever. NASA's team has kept them alive by shutting down non-essential systems, squeezing every bit of science from their dwindling power. The journey is a race against time, as the probes will eventually fall silent. But every day, they send back data from a realm no human has ever seen. Their odyssey is a triumph of engineering and imagination. The Voyagers are our eyes in the cosmic dark. In 2012, Voyager 1's instruments detected a sudden drop in solar particles and a spike in galactic cosmic rays. It had crossed the Heliopause, leaving the sun's magnetic bubble and entering interstellar space. For the first time, a human-made object was truly between the stars. Voyager 2 followed in 2018, confirming the transition with its still-functioning plasma detector. Having two crossings from different locations revealed the Heliopause isn't a perfect sphere but a dented, dynamic boundary. The transition was surprisingly sharp, more like a cliff than a shoreline. The magnetic field didn't flip as expected but instead grew stronger at the boundary. Now, the Voyagers are sampling the interstellar medium directly, measuring its density, composition, and magnetic field. Everything they detect now is about the galaxy itself, not our sun. It's as if our ship has left the harbor and entered the open ocean. The data is pristine, unfiltered by the sun's influence. This is a new era of exploration, one that only the Voyagers have begun. Their journey into interstellar space is a milestone for humanity. We are no longer just observers, we are participants in the galaxy. The Voyagers have opened the door to the great beyond. Just before reaching the Heliopause, the Voyagers detected something unexpected, a hydrogen wall. This isn't a solid barrier, but a region where interstellar hydrogen piles up, energized by the sun's ultraviolet light. It forms a vast, hot boundary around our solar system, like a bow wave in front of a ship. The Voyagers measured this wall directly, confirming a theory first hinted at by Hubble. The hydrogen wall shows that the boundary between our solar system and the galaxy is dynamic and structured. It's not actually on fire, but it's hot by space standards, though far too thin to feel. This wall helps shield us from harsh cosmic rays, acting as a filter for life on Earth. Understanding it helps us imagine what conditions might be like around other stars. The Voyager's discovery adds a new piece to the puzzle of habitability in the universe. Our solar system's edge is more complex and more fascinating than we ever guessed. The heliosheath, the region just inside the heliopause, turned out to be a chaotic zone of magnetic bubbles. These bubbles, twisted by the sun's magnetic field, trap solar wind particles and create wild fluctuations in Voyager's readings. This discovery upended old models, revealing a frothy, dynamic boundary instead of a smooth transition. The magnetic field grew stronger and more compressed near the edge, but didn't realign as expected. Instead, the sun's and galaxies' magnetic fields coexisted, separated by a razor-thin boundary. This magnetic highway allowed particles to flow in and out, connecting our solar system to the galaxy. After crossing the heliopause, Voyager 1 detected shock waves, tsunamis and interstellar plasma, triggered by solar eruptions. Even beyond the heliosphere, the sun's influence can still be felt. The Voyagers showed us that the edge of our solar system is a place of constant change and cosmic connection. The boundary is alive with strange physics we're only beginning to understand. Why does this matter? The Voyager probes have given us our first direct look at the boundary between our solar system and the galaxy. Their discoveries, magnetic bubbles, the hydrogen wall, the sharp heliopause, have rewritten the textbooks. This data is crucial for understanding how stars interact with their surroundings and what makes a system habitable. The Voyagers are templates for exploring other star systems, helping us imagine what lies beyond. On a human level, their journey is a symbol of our curiosity and drive to explore. These aging spacecraft are our silent ambassadors, carrying a message from Earth into the unknown. As long as they have power, they'll keep sending back data from the frontier. The Voyagers have shown us the edge of home and expanded the boundaries of human knowledge. Their story is far from over. They remind us that exploration is endless, and the universe is waiting. Keep looking up.